Good morning, children. This is Shivalsa speaking. Children, here in this video, we will discuss about something very important topic from the chapter of class 10 CBSE Physics, magnetic effect of electric current. So here in this video, we will understand about polarity of a magnet. Let's see what are the poles, how the poles exist in a magnet. Let us assume a bar magnet. This is a bar magnet having two poles, one is north, another one is south. Since we know that the magnetic field lines comes out of north and moves towards south, like this, coming out of north and moving towards south. So the field lines are actually getting completed through outside and from inside as well. So if we look at the diagram, the field lines are actually starting from north, going towards south, and through the inside of the magnet, it's again coming back from south to north. Same way, like these also, coming out of north, going inside and forming a complete circle or a circular path. Since these field lines are intersecting over here, but since we know that field lines of forces, they never intersect each other, and the magnetic fields are strongest near the poles. In the previous class, we had a discussion about it, how the field lines actually are determined, how it was first discovered, or rather how it was calculated using one pivot magnet, using a compasses. How can we measure, how can we find the direction of the magnetic field lines? We had a discussion about it in the previous class. So children, we know that a bar magnet is a dipole magnet having north and south. I believe it's clear to everyone. So now the confusion started with a ring magnet, whether it has got poles or not. If so, where are the poles? In which direction? Since it is completely a circular. Children, if we consider one bar magnet having north and south poles, let us assume that this bar magnet is getting bent and its poles are coming closer to each other, like this, north and south. So if it keeps on bending, a time will come like the magnet will look like somewhat like this. This is north and this is south. It is quite looking like a horseshoe magnet or a U-shaped magnet. We have seen U-shaped magnet look like this, having two poles, north and south. Children, we should always keep in mind one thing: monopole do not exist. If somewhere is a pole, so the other end or other side automatically behaves like opposite pole, automatically. So monopole technically do not exist. So whether it is a bar magnet or a U-shaped magnet, everywhere we will find two poles, because all these magnets are dipole magnets. Now question arises that whether a ring magnet is having any pole or not. So as we as we are bringing these two poles, north and south, closer and closer, a time will come when this north and south will attach. We are just assuming it. We are assuming it that both the poles are coming closer to each other. A time will come when the north and south will attach to each other, and it will produce one circular magnet or a ring magnet. Now question is whether it has got any poles or not. Children, let me make this concept very easier to you all. Let us assume a bar magnet is standing like this. Okay. Now let us assume this is north and this is south pole. If we can if we can, rub the edges, and if you give a circular shape like this, if we remove these edges by rubbing or something, by doing something, if you can remove the edges, it will take a shape of a cylindrical magnet. Yes or no, children? If we can, rub the edges like these edges, if you can remove these edges by sharpening the edges or by rubbing, it will take a shape of a cylindrical magnet, right? So it's still having two poles, north and south, because it has come from this bar magnet only. The only thing we did over here, we have just cleared these edges and we have given a circular in shape. We have given a circular shape and it is looking like a cylinder. So this cylinder is definitely having two poles, north and south. Right now, if we can make a hollow, if we can make a hole from inside like this, or if we can clear the middle part of it like this, it will take a shape of a hollow cylinder. Okay, like this. Now, after obtaining this hollow cylinder, if we give a cut right from here, if we can make multiple pieces, and each piece will come out, will look like a ring magnet. So since it had two poles, north and south, so this ring magnet will still have two poles. One is north and other one is south. I know it has not been cleared yet. Children, a ring magnet, where these poles will exist, where the poles will lie, it totally depends upon the orientation of magnetization. Now, what's the meaning of it? Usually, a ring magnet has two faces. One face towards up, one face towards the bottom. So the face towards the up, facing up, is actually north pole, and the face towards the bottom is actually south pole. This kind of poles are known as axial poles. Axial. Okay? When the poles exist on the axis, that kind of poles are called axial poles. So if I consider one ring magnet, it must have poles north and south, because monopole do not exist. North and south, these dipoles at the two faces. One face is north, one face is south. This kind of poles are known as axial poles. There are another kind of poles, or another type or category of poles exist in a ring magnet. That is called radial poles. Now, what is radial poles? If you look at a ring magnet, obviously there are two circumferences. One is towards the outside, one is along the outside, one is inside. So the outside one will behave like one pole, and the inside one will behave like another pole, or the opposite pole. It could be north or south. So the poles will lie, if the poles lie in this direction, the outer circumference as north or south, and the inside circumference is as north or south, just like opposite of the first one. These kind of poles are known as radial poles, where north and south lies at the two different circumferences. So this kind of poles are known as radial poles. So a ring magnet can have axial poles, at the same time radial poles as well. One more. When the orientation of magnetization is done in such a way on a ring magnet, maybe you suppose you are making a ring magnet Maybe that could be neodymium magnet, or simply by using iron or a nickel, or a alloy of iron and nickel. Suppose if you're making a like if you're making an alloy, I mean to say, if you're making a magnet using an alloy of iron or nickel, or just simply by neodymium magnet. Now, what is neodymium magnets? Neodymium magnets are the alloys of neodymium metal, iron, and boron. When these three substances are taken together in a particular ratio, that alloy can be used as a magnet, or that can be converted into a magnet just by keeping in a strong magnetic field. By doing magnetization, we can make this alloy a magnet. So since we know that neodymium magnets are one of the strongest magnet, the most powerful magnet so far human have made till date. So suppose I'm making one neodymium magnet, this one. I want to make a ring magnet using these substances. If one side, like this one, if one half is suppose North Pole and other half is suppose South Pole, suppose this one, I'm marking it with a zigzag line. This one is a North Pole and this one as a South Pole. Such magnets or such poles are known as diametric pole. Diametric poles. Let me do the figures once again. When a ring magnet is taken in this way, it's an axis passing through right from the center. The upper face is showing North Pole, down face is showing South Pole. These poles are known as axial poles. Next one, another ring magnet. When the magnetization is done in such a way, the outer circumference is having North Pole and the inner circumference is as South Pole. These poles are known as radial poles. When a ring magnet is made in such a way that one half is, this half is behaving like a North Pole and another half is behaving like a South Pole, this kind of poles are known as diametric poles. Other than these three types of dipoles, there could be multipoles in ring magnets. The meaning of multipoles of ring magnets means, suppose this part is north and south, this part is south and north, this part is north and south, means multiple times the poles are taken. All are north south, north south, north south, like this. These kind of ring magnets have got multiple poles, multiple times north and south. They are called multipoles magnet, multipoles ring magnet. So children, I'm pretty much clear, I believe, that a ring magnet has poles at multiple directions. One is axis wise, one is radial wise, one is diametric wise, one could be how many times it has been taken, that wise. So it totally depends upon the orientation of magnetization. If you simply consider one ring magnet, if you purchase from the market, that magnet, if it is a normal one, normal magnetization is done or normal orientation is done, it will have axial as well as radial. So that is why sometimes we say that the ring magnet do not have any poles, but actually the inside is something else. If you look at inside, you will find, suppose, see, if you break one ring magnet, suppose you have broken one ring magnet like this. Each pieces or each curvatures will behave like a bar magnet, or simply by keeping multiple bar magnets like this, one after one, one after one, one after one, north south, north south, north south. In this way, you can actually create one ring magnet. So ring magnets are nothing but a what? It's a combination of multiple bar magnets in a circular way, and it behaves like a ring magnet. So if you are still confused that whether a ring magnet has got a poles or not, the answer is yes, it has got poles. But if you actually assume, at a horizontal line wise, or suppose keeping a magnet at the horizontal axis, if you try to figure out, you will not be able to understand where is actually the pole is located, because multiple bar magnets are forming a circular or a ring magnet. So technically you don't have any poles at the horizontal plane or a horizontal axis. It doesn't have any poles. Until and unless you are not trying to understand, or until unless you are not able to understand what are the axial poles, what are the radial poles, or the diametric poles, you will not be able to figure out where these poles are actually aligned. So always remember that a ring magnet can have poles at multiple directions, axis wise, radial wise, diametric wise, and simply just by joining multiple bar magnets, if you join the multiple bar magnets, it will produce a loop where you will not find any poles in this consideration. You will not find any poles. But if you break a ring magnet, you will get multiple bar magnets. And that condition in a ring magnet or a circular magnet, it must have the poles axis wise and radial wise. So axial wise or radial wise or diametric wise, scientists make or physicists make the magnets just by changing the orientation of magnetization. So the answer for this query, that whether a ring magnet has poles or not, answer is yes, it has poles. It has axial poles, radial poles, diametric poles. Depends upon the orientation of magnetization. Because sometimes we make different types of ring magnet, depends upon our requirement. So ring magnet, axis wise, north and south, radial wise, outer circumference, inside circumference, and diametric wise, one half is north and one half is south. So just to avoid the confusion, we sometimes say to the children that ring magnet do not have any poles, but it's actually not. Ring magnet has got poles, depends upon the orientation of magnetization. So the common one what we get from the market, the ring magnets are found in sound speakers. That kind of ring magnets have the poles axis wise and radial wise. Just by simply, if you want to check, if you want to check whether a ring magnet has got a poles or not, simply what can you do? You can take the ring magnet this way, and you can tie this magnet with a piece of thread and just hang it. The moment it is suspended, it will keep on freely moving, and once it is in rest, it will definitely show two directions or two direction of earth. One is north pole, other one is south pole. So since it's resting at north and south, it proves that ring magnet has got poles. Or simply you can try this experiment in other way as well. Suppose you have taken a plate contains water. Now you just use one thermocol board or something which floats on water. Now place the ring magnet in this way and leave it. We'll find that after a while this ring magnet is actually directing north and south. Now Uh, One question I frequently get from the students that, sir, since Earth is, one of the biggest magnet we so far consider, Earth itself a magnet. So Earth has got poles. Of course, it has got poles. One is North Pole and another one is South Pole. So these poles of Earth are known as geographical poles. One is the north end and the south end of Earth. At the same time, Earth has got two poles which are known as magnetic poles of Earth. It lies north and south this way. This line which I'm drawing here right now, this one is magnetic north and magnetic south pole of Earth. And this one, these two are the geographical poles of Earth, north and south. Now the question is that why they are not at the same place, why they are not overlapping on each other, why they are not collinear. The answer is Earth core is actually, which is filled with molten nickel and iron, which is spinning inside the Earth, which is at the center of Earth, which is known as a core of Earth, which is spinning. And this alignment of the Earth core is not along the north and south pole of the geographic poles or the geographic poles of Earth. It is not aligned accordingly. It is slightly 15 degree shifted from the geographical north and south pole. That's why Earth has got two types of poles. One is geographical poles, other one is magnetic poles. Children, you'll be surprised to know this north and south pole can be shifted, or it is actually getting shifted. It takes somewhat 40,000 to 1 lakh years to change completely from shift from north to south and south to north. If you check a record of British, geographical survey, in the year of 1830, the magnetic pole of Earth, the north magnetic pole of Earth was somewhere the coastal regions of Canada. And it is 2024, in the recent survey it has been found that it is actually near the Canada, inside the Canada. So first it was inside, it was in the year of 1830, the north magnetic pole was inside the Canada, and in the 2024 it has been shifted towards the coastal region of Canada. And this shifting is taking place somewhat 15 kilometer per year. This shifting is taking place somewhat 15 to 16 kilometer per year. Every year the magnetic north pole of Earth is shifting this way, like this. It was in the year of 1830, it was inside the Canada, and in 2024 the magnetic north pole is around the coastal region of Canada. It is actually shifting. Perhaps after 40,000 years or 1 lakh years it will be completely changed. And one notably changes has been seen that since it's going closer to the north pole, the magnetic north pole is going closer to the geographical pole of Earth, the change of shifting, it is actually accelerating. It is actually happening very fast now, quite faster. In last 200 years before, the shifting was somewhat 9 kilometer per year or 10 kilometer per year. Now it has become 15 kilometer per year, and it is actually changing. Why? Because the core is spinning inside. The core itself is spinning inside the Earth core. That is why there is a change in the shift of magnetic poles of Earth. Perhaps after 40,000 years, this magnetic north pole will be totally in this place, on and the south magnetic pole will be totally shifted to this place. So we don't have, the scientists do not have the accurate data when this the change or the shifting of the poles will actually take place, though we don't have the accurate data. But it has been seen that in last 200 years of data, the British geological survey, the data from British Geological Survey, it has been seen 200 years before, the magnetic North Pole was lying somewhere inside the Canada, and after 200 years it has been shifted to somewhat the Arctic seaside, the coastal regions of Canada. And the speed or the velocity of the shifting of the poles were somewhat 9 kilometer per year. And it has been seen that it is very close to the geographical North Pole. The magnetic North Pole is very close to the geographical North Pole, and the change of shifting is somewhat 15 kilometer per year. Okay, so this magnetic pole of Earth can be shifted, and since the core is spinning inside, and the north and south pole of Earth is, the geographical north and south pole of Earth is fixed. That will never be changed until and unless a big something is happening, maybe a collision of asteroid with Earth, or maybe atomic explosions or nuclear bomb explosions. That sometime actually causes the change of little bit changing in alignment of north and south, geographical north and south pole of Earth. But until and unless such things are not occurring, not happening, the geographical north and south pole will never be changed. But magnetic poles of Earth, such as north and south pole, can be shifted. It is actually getting shifted, not can be, it is actually getting shifted. Since I believe that you are all aware about the news that the China has built a dam on a river that is one of the the biggest dam ever built on river on Earth. That has actually caused Earth 1 second faster. I mean, the Earth rotates on its axis. It has become 1 second faster. The rotational speed of Earth has been changed. Just 1 second, just by 1 second, and that 1 second of change can cause a very big change. Can cause a very big change on Earth in terms of data communication through satellites, the real-time business. It can affect many things. So regarding this topic, we will have a discussion on someday, since the video is getting the video is becoming quite longer. So I hope that it's clear that where the poles of north and south poles of a ring magnet exist. It can exist at many directions, axis wise, radial wise, diametric wise. That's why, just to avoid such confusions among the children, we simply say that it do not have any poles, but actually it lies axis wise, radial wise, diametric wise, and all. So I hope my explanation is clear to everyone. If you still have got any confusions or doubts, please feel free to ask. I'll happy to answer your questions, answer your queries. Till then, thank you so much. Thank you, everyone.